Okay, hi, here's a small program that I wrote that shows how to use a nested loop to factor a number. Okay, so basically, um, you can factor any number from 1 to 10 using this example, but I'm going to increase it to 100. But first, we're going to do it this way. So I'm going to run the program, and it asks me for a number. So I'll put 8, and now it's going to list all the factors of 8. Okay, every possible way that you can make the number 8 by multiplying is here. 8 times 1, 4 times 2, 2 times 4, 1 times 8. So if you want to find the factors of 10, here you go. 10 times 1, 5 times 2, 2 times 5, 1 times 10. This computer actually is pretty powerful in its mathematics capabilities. And I'm going to be doing a couple videos, probably some more math videos. I did some in the past, and I'm thinking about doing some more. This is another one that I think is pretty interesting. And they have a lot of formulas. If you look in the back of your extended color basic manual, you'll find formulas for algebra and calculus. They have the quadratic formula back there. They have how to I don't know how you say it. If you have a negative exponent, like a to the negative 1, that would equal 1 over a, I think. And things like that. So I'm going to get into that and see what I can pull out of there that would be interesting to look at. And another thing to mention is that if you are an honors math student, or if you were an honors math student, then you could probably do, let's put it another way, if you're not an honors math student, then you're not going to be able to use your color computer's math functions to do things like sine and cosine, which is calculus, to make a sine wave, or trajectory, which would be like an object, trajectory. You need formulas to be able to make good animations sometimes, and I, for one, I'm not an honors math student, and I was never an honors math student. However, I took pre-calculus, though I don't remember anything about it. I am basically an algebra person. I passed intermediate algebra and pre-calculus, and that's about as far as I went. But the more math you know, that's really to your advantage here. You can do a lot with that, but I'll just be sticking with algebraic operations and below. I won't be doing any calculus. I don't remember calculus. Like I said, I took it pre-calc a long time ago, and I didn't do very well. They also get into in the TRS-80 manual into trigonometry, which I understand parts of, but I probably won't be doing very much with that. So let's just clear the screen and list this program and see what makes this program work. And as I said, it's a nested loop, which means it will begin with for x equals 1 to 10. So x will equal 1 until it gets to the next x, and then x will equal 2. But what happens is, in a nested loop, I have another variable here that goes for y equals 1 to 10. This will cycle 10 times and this had only cycled once, okay? So this will cycle 10 times, and the x will still be on its first cycle. When x gets to its second cycle, this will cycle 10 more times. So what this is actually doing is, it's going, if you see the program line here, if y times x equals a, now this isn't hard to understand. If you just break it down, when the program starts, it's asking for input A. Okay, so when I run it, that's what the question mark means. You can't, if I put a number like 11, I'm going to get an, nothing's going to happen. Okay, because our range here is 1 to 10, not to 11. So it has to be a valid number. Say if I put in 10, then A is 10 here. So if x times y equals 10, then it will print x times y equals A. Okay, so if you print a variable with no quotations, you can't use quotation marks. Okay, quotation marks are only for string values, like letters, okay, or specific numbers. Okay, so print y, if I try to print y right now, it's going to give me the last value that I put in for the input. Actually, wow, that's funny. I don't know why that printed 11. That is really strange. Print A. A should be the 11, not Y. I don't know why that did that. I have no idea. But, so if I run the program again and I put in 5, the only factors of 5 are 1 and 5. Okay, and if I print this input A, it's the 5 that I just put in. Okay, so after we get our input, say it's 10. Now, on the first cycle, x equals 1. So our first y is also 1. 1 times 1 does not equal 10. 2 times 1 does not equal 10. Nor does 3 or 4 times 1 or 5 times 1 or 6 times 1, 7. The only thing that would equal 10 here is 10 times 1. So if we run this, that is our first result, 10 times 1. Okay? Now, if I list this again, you can see it identified here, if, then, print. So the y equaled 10, print y, print 10. Now in quotes I have the multiplication sign because that's a string. Then I have an x, parentheses don't matter, you can put them there, it's just aesthetic. You don't really need them there. Actually, I should probably edit 6 and make it, you know, look uniform. And so now print y, again 10, times x. on its first phase is always going to be 1 all the way down the line. Y is going to keep changing because it's next Y, next Y. 1, 2, 3, 4, all the way until it gets to 10. Then it's going to say, oh yeah, 10 times 1 equals 10. So now it will then print 10 times, in parentheses, x is 1, equals is also in parentheses, it's a string, it has to be identified in quotation marks, and then so we have 10 times 1 equals 10. That will be our first result. Then it will cycle back to x, and x will become 2. It'll go through the whole routine again, and there's nothing times 2 that equals 10 except for 5. So when y equals 5 and x equals 2, it'll equal 10, and we'll get our second result. 5 times 2 equals 10. And it's going to do the same thing for all of these. I think it's going to go through 100 numbers because 10 times 10. We have y equaling 10 at its max and x equaling 10. So yes, it will go through 100 cycles, and the computer does it very quickly. Look, it goes through 100 cycles in probably less than a second. And now you have all of your factors of 10. When when y equals 2 and x equals 5, it'll equal 10, and y equals 1, x equals 10, 10. You see where I'm going with this. So this is incredibly simple, but again, it's the principle that matters. Like I said in other videos, you have to base your programs on principles that work, and they become part of a bigger program, like a card game program or something like that. I'm probably going to be summing up a lot of these smaller things that made my bigger programs work. And just for fun here, before I end this video, I'm going to edit line 4, and I'm going to increase this, like I said, to 100, and I'm going to edit line 5, and I'm going to increase that to 100. So now, let's see, what is 100 times, the little diamond on the color computer is your times symbol. So 100 times 100 equals 10,000. Now before it was going through 100 cycles, now it's going to go through 10,000 cycles. And I don't know how long that's going to take. I've never tried this before. So we're going to have to edit number 2 and add another 0 here. And this is just for purposes of the program. This could say anything and it wouldn't matter. What matters is what you have here, your actual parameters. This is just for aesthetics, so you know the program, identifies itself. Now I would like to know what all of the factors of 100 are. And remember, it's going through 10,000 cycles here, so it's going to be a little longer. See, but that's the whole purpose here. It's not about speed, it's about accuracy. So isn't this amazing? It's giving me all of the factors of 100 now. And this is why computers were created in the first place. So that it can do calculations like this and give you these answers. If you didn't have a computer to do this for you, you would have to do this by hand and make a factor tree. And that's what it's doing right now. It's creating a factor tree for you. And it's finding all of the factors, what times what equals 100. So we have 10 times 1, 50 times 2, 25 times 4, 20 times 5. That's 5 $20 bills in your wallet equals $100. Okay, 10 tens. And then everything gets reversed after this. This right here is probably, you call this an equilibrium line. If you wanted to make a graph out of this, this is your baseline here, or whatever you want to call it. And then after that, everything gets reversed. We have 25, 520, 25, 4, 425, 52, 250, 101, 100. And those are all of the factors of 100. Okay, we're going to try one more number. Let's pick a number. Let's pick a good one here. 80. I don't know all the factors of 80 offhand. I know 1 times 80, 2 times 40, 20 times 4, 16 times 5. I mean, who can do this in their mind? 10 times 8. Some of them are easy. And where it starts to reverse, 10, 8, and 8, 10, right in between there would be your equilibrium, or whatever you want to call it, your break line, if you were making a graph or something like that. This is the center right here. So, you know, remember, and it's going through 10,000 cycles, so it probably takes a minute or two to finish, but it's well worth it, and you can print this out and do whatever you need to do with it. And I'm just going to cut the program out here because it does take a long time, 2-3 minutes maybe, to go through that many cycles. But literally, I wrote 1, 2, 3, 4, 5, 6, 8 lines of code minus the CLS. Well, okay, 8 lines of code. How hard is it to write 8 lines of code? Not that hard, right? I'm sure you heard of nested loops before, but here is an application for a nested loop that anybody could use to break down a number, to find the factors. And that is the end of this video, and I'll be doing some more, probably maybe with a quadratic what is it called? Quadratic equation. Maybe some negative exponents and things like that. So that's about it for this video. Thank you for watching. Take care.